No, don't sleep. All right. Okay, so this is chemical level of organization, and it's simple, it's easy to follow through, and I promise you. Now, it may seem to have a bit of chemistry, but it's not. If you don't like chemistry, it's not the kind of chemistry that will upset you. It's just the basics, all right? And probably trust me, if you just follow carefully, I will make sure it's easy for you to grab. And if you have questions at any time, just stop me. Now, I lay more emphasis on the lecture, and so I take time with it, because for labs, what we do in the lab, you have the setup, and what we do in the lab is to look at those slides, picture them. So if we need more time, sometimes I could take a little more here and use lesser time there, okay? All right, so let's go. All right, so we are looking at chemistry, chemical nature, chemical organization of chemical level of organization. If you remember, you know that there is, if you look at organization of life, you talked about atoms, we talked about molecules, we talked about, so we have atoms, molecules, then we can be talking about either organelles, depending on how we want to talk about it, but we can just go to organisms, right? Now, oh, no, I skipped cells. All right, now, cells is the next, then we can talk about organism, or we can talk about organelles, or we can, now, so when we say chemical level of organization, we are talking about these stages, these two, right? Now, because in the real sense, without, I think, okay, maybe not your class. I was telling the class last week that there's no cell that can exist without DNA. No cell. We can talk about prokaryotic cell and eukaryotic cells that have different orientation of nucleus. Prokaryotic cell doesn't have the membrane-bound nucleus, right? Eukaryotic cells have the true nucleus, the nucleus. But what is the content of the nucleus? Is the DNA. But both of them have DNA. There's no cell without DNA. The only thing is the DNA in prokaryotic cell is just in a region. It's just the cell, it's just the DNA without a covering, a membrane band covering, the double membrane, right? But the DNA in eukaryotic cell is more organized. It is linear, a couple of them, and it has membrane band organelles, double membrane. Now, so when we look at matter, when we look at chemical level of organization, we are looking at think about that we are studying the cell in its in its chemical form. We are looking at the DNA, as all of those are chemicals. So matter, what is matter? You already know that matter is anything that have weight, right? And occupy space. So you are a matter, right? Mr. A is a matter, right? Good. Now, elements, we have about 112 types of elements, and 92 of them are naturally occurring. We have, I'll be talking about major element then the trace elements. When we talk about trace element, what can you remember? Say it out. What can you remember when we say trace elements? Trace. What can you remember? Try to remember it. I thought you studied this chapter. Okay. Don't worry, I'll get to know next week when you stop using notes. All right. When you say trace element, you are talking about elements that, what I expected that should come to your mind when you hear trace element is iodine. Iodine. I expect iodine to come through your mind because that's the element that you require in minute quantity. And so when you want to buy salt, who buys salt in Walmart here, from Walmart? All right, when you buy salt from Walmart, did you ever take note that there are some salts that have iodide, right? Iodized salt. Those are the salts that have iodine. Now, the reason, so this is a trace element. You heat it in little quantity. The body needs it in little quantity. And you remember, did I mention anything about thyroid gland here last week? Oh, good. What did I say about thyroid gland? If you forget anything, you should not forget hyperthyroid and the hism, just to make it sound good. Did I talk about that? Okay. So, thyroid gland is what is responsible for metabolism, right? That's the gland that is responsible for your metabolism, right? And we were talking about hyperthyroidism and hypothyroidism at that time. Did you remember? Very good. Now, this iodine, it is the key resource that the thyroid gland needs to function. So if iodine is not available, then there will be impairment to thyroid function. So it's a trace element, but yet very powerful, very important. You know how important metabolism is to our body, right? So if this is not available, it impairs the whole of thyroid function. All right, major elements. You have carbon, hydrogen, oxygen, nitrogen. These alone occupy about 96% of organism structure. Carbon, hydrogen, oxygen, and nitrogen. Others will continue like phosphorus, others sodium, potassium, others continue. But when we talk about elements, now when we talk about elements, what are we talking about? We are talking about what you know, hydrogen, helium. I know a song for the first 20 elements. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. You know that song, right? Oh, okay. Yeah, so for me, I can always remember the first 20 elements with that. Some people know it with LOLO or something. Just any way you're able to know it is just cool. It's good to know it, you know. Now, so generally, all of these elements, they have their chemical symbols. So when you talk of hydrogen, who can tell me the chemical symbol for hydrogen? H, right? Helium, He, right? Lithium, Li, right? Boron, B, right? Beryllium, Be. Sodium, Na. No. So the reason we don't use sodium Ns for sodium is because silicon is already, sulfur is already S. Usually we use the first letter. Now, how about calcium? Ca. Why are we not using C for calcium? Because carbon exists. Carbon is smarter, right? Carbon already took the C. Then we have potassium is P. Potassium is K. Why is potassium not P? Because phosphorus exists, and phosphorus has taken P. So sometimes, usually they use the first letter to denote their symbol, but sometimes we just have to improvise if one already exists with that. So all elements that you can ever think of that we are talking about now, they consist of matter, of atoms. They are made up of atoms. All right, let's go. I'll try to get on the things that I need to focus on. Okay, very good. Now, this is the atom we are saying. This is the functional unit of every element you can think of. So that means hydrogen, the simplest way hydrogen can appear is an atom, right? So you can have an atom of hydrogen. Now, this guy here is very interesting. You have the electron. You have the electron revolving around it. Now, inside, just like a cell, the inside consists of a nucleus. Think about it that way. And the nucleus is where you have the proton and the neutron. So the proton and the neutron add up to be the mass number. So if you want to check the mass, the weight of any atom, it is the neutron and the proton that determines it. So mass number of every atom, I will just write mass number equals proton number plus neutron number. If you are writing, that's the best way to write it. Mass number equals proton number plus neutron number. Now the proton is positive and the neutron is neutral. Revolving around it to balance it is the electron, which is negative. So think about it. Positive is inside, electron is revolving around it just to balance it. So that means electron and neutron will most of the time be the same value because they are trying to balance up each other. Does that make sense? So proton and electron will most of the time have the same value. The only case when they will not have the same value is what I'm going to put on the board here. See. Now, see my summary real fast. I don't have too much time to stay on this, but I'm going to stay on it. Now, few things I've mentioned so smartly is number one is proton number. Number two is neutron. Number three is electron. Number four is mass number. And proton equals is the same thing as atomic number. Proton number is the same thing as atomic number. So anytime you hear proton number is the same thing as atomic number. And obviously it is positive, right? We already said proton is positive. Neutron is neutral. Electron is usually the same number with proton, but it could be different. Neutron also will be different. It's not always the same number. But two cases of electron. For neutral atom, what does that mean? Atom that doesn't have any charge on it. For neutral atom, electron is equal to proton. But for charged atoms, when I say charge, another name we call it is ion. I-O-N. Have you ever heard of that? You call it ion, right? Ion. All right. Ion. For this, electron is not going to be equal to proton. Why? Because there will be difference in their charge. Charged particle means it will either be negatively charged or positively charged. Make sense? It will either be positive or negative. So, meaning that there will be difference between proton and neutron and electron. Does that make sense? Good. Now, at neutron, mass number equals proton number plus neutron number. Now, what that means is this. If I have the mass number, I can get the neutron number. Proton number, I told you, is the same thing as atomic number, right? And it is the number, it is the same number with their position on the periodic table. When I say periodic table, let me see if I have a picture of the periodic table here. I don't, unfortunately. Now, but periodic table doesn't matter to us now. Now, what matters is that when I have an ID number, you also have an ID number, right? You have your school ID number, right? You have your G number, right? Now, your G number is peculiar to you. Once you call IT or you call anyone, you need help, they ask you your G number. Once you tell them, they already know your information, right? The same way, atomic number or proton number is the ID of every element. Atomic number or proton number is the ID of every element. Now, once I hear atomic number 1, I already know that is hydrogen. Once I hear atomic number 6, I already know that is carbon. Once I hear atomic number 20, I already know that is calcium. Once I hear atomic number 11, I already know that is sodium. Once I hear atomic number 17, I already know that is chlorine. right? So the atomic number is their ID, is their G number, okay? Now, I think I've said everything about this. I don't think there's any other question there. Now, don't forget, the proton and neutron are in the nucleus. So that means the nucleus is what determines the weight of every atom. Does that make sense? Good. Electron is just spinning around it. Electron is just spinning around it. Doesn't add to the value. Now, I've talked about atomic number. I've talked about atomic mass. Atomic mass and mass number is the same. It's just mass, okay? Atomic mass is the same thing as mass number. So anywhere you hear atomic mass is the same thing as mass number, okay? All right. Now look at this. The first image there shows you hydrogen. The second image there shows you helium. The third shows you lithium. The fourth shows you neon. Hydrogen has, what is the atomic number of hydrogen? Is 1. This is hydrogen. The atomic number is 1. The mass number is 1. Helium, the atomic number is 2. The mass number is 4. Now, so it continues that way. But what I want to show you first now is part the electron follow while spinning around the nucleus. I'll talk about that. Each cell holds a limited number of electrons. Now, there is, you can see the way those are drawn. The first shell, do you remember I told you electron just revolve around, right? So inside is going to be the nucleus. The electron revolves around, and that's what we want to talk about briefly. Now, the first shell holds a maximum of 2 electrons. That's the maximum it can hold. So the first shell can hold 2 electrons. The second shell can hold up to 8 electrons. So the first shell holds 2, the second can hold 8, the third can hold 8, the fourth can hold 8, all others can hold 8. Maximum of 8, but the first one can hold the maximum of 2. Now, it may not always be complete. So for hydrogen now, hydrogen doesn't have 2. So the first shell of hydrogen will only hold 1, right? Because the shell is able to hold 2 and hydrogen only have 1. So this shell is supposed to hold 2 like this, but hydrogen only have 1. Because of that deficiency, hydrogen have 1, that means one side is empty. We will say that hydrogen is incomplete. Another word we use for incomplete is we say hydrogen is not balanced. Another word we can use is that hydrogen is unstable. Now, when it is unstable, that is why you see hydrogen everywhere, because it reacts with other elements so that it can be stable. Make sense? You know, sometimes some friends abuse you. They tell you can't stand by yourself. That's why you always hang around with friends. Have you ever heard of that? Some people cannot just be by themselves. They must hang with people. So that happens when an electron is not when any of these is not full. But if any of these is full, like helium is He. Now for helium, the first shell is the only shell it has. So for helium, the first shell is full. Do you ever see helium around anything? Do you notice? For some of you that are taking note of chemical reactions, some compounds that you have seen, have you ever seen any compound that has helium in it? No, that's it. Most of the time, people that feel comfortable that they have everything they need by themselves, they don't feel they need people in life, you always see them alone. That is helium. We call these guys, we call them noble gases. And if you take note, noble means someone that is doing well, wealthy, doing well, doesn't need help from anyone. So they are not going to connect with others. Just like this, when I say you can still do your quiz and help someone, relate with someone, people that feel they know it, not a bad thing, people that feel they know it, they won't be the person asking someone, right? Because they know it. But someone that doesn't know it is going to ask, right? So people that know it have their shell full. They are stable. But someone that doesn't know it is going to want to ask, right? Good. So that is, so these guys, or any other guy that have this full, this is first shell, second shell, third shell, fourth shell, fifth shell, continuing. Anyone that have it full, we say it is stable, it is balanced, they are non-reactive. Make sense? Good. Now, so all of the guys that are here now, first shell, I told you can only take 2, but it meaning that it can take 1, right? But the maximum it can take is 2. Second shell can hold 8. It can have 7, but the maximum it can have is 8. Can second shell have 9 electrons? No. Can third shell have 9 electrons? No. The maximum first shell can have is 2. The maximum second shell can have is 8. The maximum third shell can hold. Now, don't let this confuse you. I'm telling you that it is 8 because this, I don't want to take you to this explanation here because you don't need it. There is something they call SPDF. You don't need that. But the one I'm giving you is the basic that you will need. It is the KLM. It is 2888. So don't worry about KLM or SPDF. Just know the first shell can take 8. The second shell can take, the first shell can take 2. The second shell can take 8. The third shell can take 8. Make sense? Every other shell after the first shell can take 8. Make sense? Let's go. Now, atomic structure. Now look at this. What I'm saying will make a lot of sense by the time I'm done with this slide and you'll be excited. Now, this is sodium. How many electron is in it? How many proton number does sodium have? Let's just play with that. How many? What is the atomic number of sodium? You don't have to know it offhand, but I'm just asking. 11, thank you. So atomic number of sodium is 11. So what is the proton number? Thank you. It's also 11. Proton number is also 11. What is going to be the neutron number?
11.
No. Neutron number is not 11. Because neutron number can change. It can be different. Neutron number is not always the same as proton number. Neutron number is, what is the mass number of sodium? If we know the mass number, then we know the neutron number. Mass number is 23. Then the proton number is going to be 23 minus 11. You remember? The mass number, proton plus neutron, right? So that means the proton number is 23 minus 11, right? So what's the neutron number?
12.
Thank you. Then the electron is going to be what?
11.
Thank you. Wow, you guys are doing great. You are the most brilliant set of students I've ever met. I'm going to tell my next class too. Alright. I've told some class today. Some member of the class today. And I was telling them I'll tell my evening class the same. Alright. Now, these are standard for sodium, right? Now, electrons, we already know that the electron is 11. Do you know the smart thing I can do? The first shell is going to have 2, right? The second shell is going to have 8, right? How many will the third shell have?
8.
The third shell can have 8. It can mean that it has capacity for 8. But how many does it have now? 2, 8. 2 plus 8? 10. How many do we have left? 1. So 2H1. So is sodium stable or unstable?
Unstable.
It is unstable. Why is it unstable?
Because it's not full.
Because it has just 1 instead of 8. Right? Now, will sodium be reactive or it will be non-reactive? It will be reactive because it is unstable. It needs something. Now, that's number 1. So let's keep Mr. Sodium here. Now, let's go to Miss Chlorine. I will connect these together and we'll be fine. So Mr. Sodium is there. It has 1 and is waiting to be stable. Now let's go to Mr. Chlorine. Miss Chlorine. Chlorine, I hope you can see there, right? Sodium is Na, but it's spelled sodium. Na is from natrium because the Greek word is natrium. Now, what is the atomic number of chlorine?
17.
Thank you. Wow. It's 17. It is also the same thing as the proton number, right? Thank you. Now, what is the neutron number of chlorine?
18.
18. Why did you say 18?
Because the mass is 35. No,
Oh,
what?
thank you. Go ahead.
I think that's right.
All right, we'll come there. Give me your value when you get there. Electron number is the mass number. All right, so what's the electron number of chlorine? It's 17 too, right? Then what's the mass number?
35.4.
Actually, it's 35.5 we use normally,
Yeah.
just for standard. So you are correct. It's 35.4 something. So we just use 35.5. So what is so if we do this, then the neutron number is going to be,
18.
usually we use 18 for it, right? Normally it should be 17.5, right? No, it should be 18.5, but we just use 18 for the neutron number, okay? Now, so if this is the electron, which is what we were just playing around all of that, this is what we need, right? The electron number. So what's going to be the first shell?
2.
Thank you. Second shell?
8.
Good. Third shell?
8. 7.
Okay. Now, who said 7? The person that said 7 is my best friend in this class. Who said 7? Somebody will talk now. Who said 7? Thank you. Why didn't you talk before? Now, can you tell us why you have 7?
Because the total electron number is 17.
Total is 17, then
2 plus 8 is 10,
2 plus 8 is 10,
which means there's 7 in there.
meaning that we have 7 left. So the 7 is going to be here. Now, is sister chlorine or miss chlorine, is it stable?
Unstable.
Unstable. Thank you. And the reason it's unstable is because the outermost shell does not have H, right? And here also is unstable because the outermost shell does not have H, right? Now, since the outermost shell does not have H, yeah, I'm not able to capture the recording here, but it's okay. Since the outermost shell is not H, then they are not stable. So both of them are not stable. Did you notice that you see chlorine in almost a lot of compounds? Do you notice that you see sodium in a lot of compounds too? Good. As a matter of fact, the table salt you eat that we say contain iodine is sodium chloride, sodium and chlorine. Now, how this outermost shell, it is electron we are talking about here, right? This outermost shell, the number of electrons in the outermost shell, we call it valence electron. Valence electron. That's the name we call the number of electrons in the outermost shell. So if I ask you what's the valence electron of chlorine, what is it? 7. What is the valence electron of sodium? 1. All right. Now, so that happened. Now, what is the relevance of what I'm doing on the board? I'm going to show you now in a bit. What is the relevance of what I'm doing on the board now is to tell you how and why chemicals react. Now, since these guys are not stable, then they are going to react, right? Now, the first kind of, the fact that they react together, when chemical elements react together, the way they can react together is to form bond with themselves. Now, the kind of bond they form is what I want to show you now. The first kind of bond is what we call ionic bond. This ionic bond is a mechanism that they use in transferring electrons to themselves. You know, you just notice that your friend does not have some money on him, and you have $1,000, your friend has $0. Then you just transfer some $200 to your friend. You transfer to your friend. Your friend didn't give you anything. You just transfer to the guy. And the guy has never given you money ever. You are the one that transferred. You lost $200. He gained $200. The same thing between sodium and chlorine. They can do that kind of reaction. Now, sodium will lose this one electron and chlorine will gain the electron. When this happens, we call it ionic bond. So it's the transfer of electron between a non-metal and a metal. The non-metal, the metal is this guy, that's the non-metal. So I will take it again. Ionic bond is a transfer of electron between a non-metal and a metal.
When they join together, then would it be 2, 8, 8, and would they be stable, or would it be
I will talk
4,
about that
16,
now. Very good.
then 8?
I will talk about that now. Thank you. I like the fact that you are thinking. Now, if this loses this electron, -1, right? Because it's going to transfer it to that guy. When you transfer, the last time you transferred $200 to your friend, do you still have the $200 in your account? Mm-hmm. Except Chase decide to reverse the transaction. Now, by the time sodium gives this out, now this is it. This is sodium, Na+. Now I'm going to come right here because to have it on coverage. If I have the light on, will that still be fine for you guys? Okay, if it will be fine, it will be better. I mean, this first for you, right? So that you can still look at it afterwards. I'm going to clean this, and I will try to limit my writings to this side from now. I'll write in there because of the PowerPoint so that I could write on some things there. Now, what do we make already of sodium? Sodium is 2H1, right? I thought I would hear yes.
Yes.
Thank you. Sodium is 2H1. Then chlorine is what? 2H7. Now, this is the normal sodium, the neutral sodium. This sodium guy can lose this one and transfer it. Don't forget the word transfer. We are looking at ionic bond. Transfer. Then this guy can gain it when sodium transfers it, right? Now, when sodium transfers one electron, it loses the electron, right? And this is going to gain the electron, right? Good. Don't let me cancel it so that you can still know it's one. Now, what is going to happen is this. Once sodium loses that, sodium is going to become Na+. The meaning of Na+ is that sodium has become 2/8. The reason, what we mean by 2/8 is that sodium has transferred 1 to chlorine, right? The moment it transfers this to chlorine, sodium becomes 10 electrons because it has lost 1 now. So we are not going to write this sodium like this again. Do you know why? We still need to note it that sodium has 11 electrons originally. But now it has lost 1 by giving 1 to chlorine. So we need to write Na+, so that anybody that sees sodium will still respect sodium, that sodium has 11 electrons, but it only transferred 1 to chlorine. So this one means +1. If it is 2, we are going to write 2+ or so. But since it is just 1, that's why we leave it as Na+. All right? It's saying that sodium used to have 1 more, but it has lost it to chlorine. Does that make sense? So now, this sodium is an ion. Why? Because it has charge on it. Now, what is chlorine going to be? Who can guess what chlorine will be? Now, chlorine is going to be 2A what?
8.
Because it has gotten 1. Now, what is the charge that will be on chlorine? Now, why is it having a negative? You are correct. -1, right? But we don't write 1 there because negative just means 1, right? Now, since it's 1, why do you think it's negative and not positive? Because it gained an electron. Now, when you gain something, it should be plus, right? But this case, it gained a negative because electron is measured in negative. An electron is negative on its own. It's like you got some credit, you are in debt. Does that make sense? If you got credit from Discover, you have more, but you are owing more, right? Does it make sense?
Yes.
So what you have, if you have credit from Discover, it's different from when you have money from Chase. If Chase just decide to bless you with $200 and Discover gave you $200, they increase your credit limit. You have more money from Discover, but you are owing the bank more too, right? So you are going to have a negative. Does this make sense to everyone? So this is ionic bond. Now, there's another kind of bond that is more interesting than ionic bond. Very, very interesting. Now, because, can I clean this? Now, it's more interesting because you are not going to be owing anything. Now, when I say it's interesting, I mean it. The other kind of bond is called covalent bond. This is very, very interesting, actually. It's covalent bond. And covalent bond, anytime you hear of covalent bond, think of sharing. Sharing is fun, right? All right, can we share? I was going to sing that song, My Baby Sings. All right. Now, covalent bond means they are sharing electron. They are not transferring it. They are just sharing it. So, you know, for ionic, sodium lost the bond so that it can be balanced, but it losing something to go back to its smaller stage. But chlorine is gaining one to be balanced, right? But here, they are going to share it together. Now think about it. It's as simple as what happened to hydrogen. Now, hydrogen has one electron, right? Another hydrogen have one electron. They are going to couple together to have two electrons together. So if I do this by the side now, I'm just going to draw the two of them together. I will shade this to differentiate the electrons. Then I'm going to have one electron here. This is this one. Then this one here. Now, when I close this ring, and I'm counting electron of this ring, how many electrons does this have? 2. When I close this, and I'm counting the one on this ring, how many does it have? 2. So they both have 2 electrons in their outermost shell. So this we call H2, hydrogen molecule. So this is a kind of bond. So this is sharing of electron between non-metals. And usually it forms molecule. Does it make sense? The same thing. 2 electrons are needed to make a bond. You can note that for people that are writing. I expect everybody to be writing anyway. 2 electrons are needed to make a bond. So 2 electrons, 1 bond. So if I need 2 bonds, I need 4 electrons. Make sense? I need 4 electrons from 2 bonds. If I need 3 bonds, I need 6 electrons. This is what happened in hydrogen. If you are thinking of nitrogen, what number is nitrogen? What's the atomic number of nitrogen? So I'll just do N to reduce my writing time. Nitrogen is how many electrons? I mean, what is the mass number of nitrogen?
7.
Thank you. So 7, meaning that it is 2, 5, right? So there are 5 valence electrons in the outermost shell. Does that make sense? Good. So that means it remains 3 for it to be complete, right? Good. So now they are going to have this here. So this is 1. This is 1. Okay. Now how did I come across this? I'm going to write. I don't want to take you through this now, but I'll quickly do it. So this is the 2 inside, the one outside. Usually when you want to, the one outside should have 8, right? But nitrogen only have 5. Now, when you want to fill the one outside, there is a rule that says you fill single before you fill double. Now, single field before doubling. I will explain what that means. So now, this is going to be, I'm doing nitrogen, right? So now we are going to have this, I'll do it real quick and I'll take it back. Now this is nitrogen, it is 2, 5. Now how do I put the 5? I'll put 1 here, 2, 3, 4. I will not put 2 straight in one location. It's a rule. Sometimes you see textbook draw it together. It's okay? But I'm just telling you the actual rule. Now, when you put 1, how many do I have outside now? 4. I did 1 more. Then I will continue to double. So out of 5, I already have 4. Then I will double, meaning that I have 5 now. So how many do I have that is unpaired on the outermost shell? 3. So 1, 2, 3. So that's what I have here. So I have the 3 unpaired that are ready to react. Is this ready to react with something else? No. This can no longer react. But once it has once these other 3 react, then the outermost shell will be full. Does that make sense? You have a question?
No.
Okay. Now, so this 1, 2, 3 is what I have here for this. Then the second nitrogen also have is 1, 2, 3, right? These 3 are the ones that are ready to pair so that it will behave. So what is going to happen is when you get home, you have time, you can draw it like this. All right? I'm drawing it like this just to save time. Now, so what is going to happen now is that you now have 3 electrons here that are not paired. 1, 2, 3. Then the other nitrogen also have 3 that are not paired. And then when they're going to come together, they will both form bond. So this is going to form a bond with this. This is going to form a bond with this. And this is going to form a bond with this. How many bonds do I have? I have 3 bonds. So this kind of bond, we call it triple covalent bond. It's still covalent bond, but now it is triple covalent bond. Does it make sense? Triple because it's 3 times. If it is double, it's going to be double covalent bond. But what's the name of the bond here? Single covalent bond. Make sense? Good. Who is tired? I want to go home. Don't worry, I'll release you. I'll let you go soon, okay? Just follow with me. The other kind of bond, there is still this one bond. Let me see if we have to really cover it. Good, we'll get it. Now, this is it. You know, I'm talking too much on some slides. What that means is that by the time I get to those slides, I'll just go through because I've explained it already. So don't fret. I've talked about ionic bond, right? I've talked about covalent bond. What's different between ionic and covalent bond? Ionic bond is transfer, covalent bond is sharing. Now, think about something with me. Can I clean this? I'm going to ask you a question real quick. If you answer me the question, the first person to answer the question will have 1 point to his quiz. 1 point to his quiz means 10%. I mean 10% of the quiz question. So if you had missed one question on the quiz today, that means you missed 10. You had 90, right? Instead of 100, right? So if you answer the question, the first person to answer this question is going to have 10 to the quiz. So covalent bond, I'm not asking the question yet. Covalent bond, I already told you that it can be single covalent bond, right? Wow, I'm getting serious responses now. Then it can also be double covalent bond, right? Even Matt's voice is so loud and busy, and I'm like, okay, he's ready to answer my question. Then this can be triple covalent bond, right? Oh, so you guys are trying to reduce your voice so that I don't talk again. All right. You don't know if I'm asking the question already. All right, now, I told you this type of covalent bond exists, right? You remember I didn't say anything about types of ionic bond, right? Good. Now, there's another form of covalent bond. The form of covalent bond, number one form, I'll just call it forms of covalent bond. Number one is polar covalent bond and non-polar covalent. Anytime you hear of covalent bond, what should come to your mind? Thank you. Who was the first person to say that? You have 10 points. That was not the question. So the question is going to come unexpectedly too. But you have 10 points, okay? But you have 10 points, okay? Just remind me you have 10 points. You can either send me an email or you get it before I leave. Now the question is also going to come like that. It's not going to be a special question. It's just going to come like maybe I'm writing and I'm saying something and anybody that says it first get the answer. Get the point. As a matter of fact, what I just asked him is difficult than the question I want to ask. The question I want to ask is just a question. All right. Now, form of covalent bond is polar or non-polar. Now, listen. When I said covalent bond involves sharing of electron, will sharing always be the same, be equal? No. Who said no first? I heard your voice, right? I heard a man's voice. Is it you? Are you the one that said no? He said it first. All right, so you have your point. That's the question I wanted to ask. All right, I'm still going to ask more. And really, I'm still going to ask more questions, and that's the way to be going. Is that I give you 5 points or 10 points to your quiz. All right, so be ready. Now, sharing will not always be equal. For some of you that has been in relationships here, is sharing always equal? No. All right, it's not always equal, right? Oh, okay, maybe I'm going to have this relationship seminar one day. Now, sharing is not going to be equal, right? Now, when sharing is not equal, it seems to be at one pole than the other pole. When it's more to one pole than the other pole, we say it is polar, unequal sharing. This actually is what happened within a water molecule. Now, water molecule, oh, I wish I have a red marker here and I would have shown you some red. But it's okay. Now, water molecule is normally drawn like this. You have hydrogen, you have oxygen. You know it's H2O, right? Yes. If you know what that molecule is H2O here, give me a thumbs up. Oh, everybody is brilliant. All right. Now, water molecule is H2O, right? But oxygen is an electronegative substance. It is more electronegative than hydrogen. So what that means is this. When you say something is more electronegative, it has attraction for electron because electron is also negative. So oxygen loves electron more than hydrogen. Does that make sense? Good. So that means even though this is a covalent reaction between hydrogen and oxygen, but one of them have electron affinity than the other. One of them have more electron affinity, meaning that one of them will attract more electron than the other. It's just like this. You like cereal. If you like cereal, who is going to... And if I'm with you now, you want to eat fries. Okay, Matt, what's your best... What do you like more?
Breakfast. Breakfast food.
Breakfast?
Yeah, breakfast food.
You like any breakfast food?
Yeah, any breakfast food. Eggs, bacon, grits. You know, breakfast food.
All right. Now, I'm afraid I can't use it now.
Oh,
now, who like fries more in this class? You like fries, right? What was it that you don't like?
What I don't like?
That you don't like?
Carrots.
Carrot. Did you say carrot?
Yes.
So if I think let's say I like carrots now, and you like fries. If we have fries, and the two of us are going to be eating it together from the same bowl or something, who is going to be eating more? You, right? The reason you are eating more is because you have affinity for it more. It will just be coming more to you, right? You will be taking more. And I'll be like, where are the fries? Now it's somewhere, right? Somewhere close to you, right? Good. Now it's because you like it more. So even though, let's say I don't like fries. Like for me, when I want to even when I want to buy fries from Chick-fil-A, I try to do without salt. Now, so if we have fries that have salt, she's going to be eating it more, right? And I will not be eating because she have affinity for it more, right? That's the same thing. Electrons Oxygen like electrons. So they are going to attract it anyway. Even though they are sharing, they are still going to attract it anyway. Right? So this is Mr. A, right? Mr. A doesn't like fries. So even though we are going to be sharing it, she's going to have more. Remind me your name again.
Maria.
Maria is going to have more of electrons because Maria likes fries. I don't like fries. Now, I don't like fries with salt. All right? Now, so that is sharing, but it's not equal. Oxygen is pulling it more, because even though they are sharing. And that's sometimes the same thing. You have a friend, you are trying to put in your breast, your friend is just getting it all from you. She's not reciprocating. She's getting it more because she just likes some benefit, right? Okay. That is unequal sharing. So it is polar unequal sharing. But there are some kind of friendship that it is mutualism. Totally mutualism. If you are enjoying, your friend is also enjoying. If you have fries, you may just even have to count it and separate it and take a count. You know, I have some friend, there's this kind of bread they sell in Nigeria that is like a loaf. It's not sliced. Do you know that kind of bread? It's a loaf. It's a loaf of bread, not sliced.
Yeah,
You know it, right?
Yeah.
Yeah. So I have a friend that if he's studying mathematics anyway, so if he's going to share bread for you, you know what he's going to do? He's going to take a ruler, then he's going to measure the bread. And so, I mean, because he's studying mathematics, so maybe that's part of the syndrome. He had to take a ruler and measure the bread to divide it equally. So that is equal sharing. So if myself and Maria are going to eat fries now, if it's unsalted fries, you know what we're going to do? We'll just take a count. We're going to count the fries and separate it into two plates because I know Maria has affinity for fries and I want to be very careful so that she doesn't outsmart me. Does that make sense?
Yeah.
All right. So those are the types of covalent bonds. I don't think you should forget covalent bond again, even if they wake you in your dream. All right. Should we go? Now, there's another kind of bond. Look at this. What is this?
Water.
Oh, somebody answered. You're not going to get point for that. All right. Now, but it's fine. I like the responses I'm getting, actually, but you guys are wonderful on a serious note. Now, this is water, right? Do you notice that when you go to the swimming pool and you jump into the water, does it look like the water molecule is separate? Like this is one H2O, this is two H2O, this is another H2O, this is another H2O. Does it look separate?
No.
No. Why? It is not separated. And even now, when you try to put water as though, if you try to pour water, you know it goes as though it's connected, as though it's glued, right? Now, there is something with water molecule that makes it connected. And we call it its cohesion property. Don't worry, I'm not going to talk about that now, but what holds it together, it's an attraction. It's not force like a bond like covalent or ionic bond. No, it's a force. It's a form of attraction that just glue them together, and that attraction we call it hydrogen bond. It's just a force of attraction. It's hydrogen bond. This is what you see. So this is one water molecule, right? So another water molecule is going to be here, and it's going to be. So this is another water molecule here, right? This is another water molecule. What's the name of this bond that joins two water molecules together? Hydrogen bond. Does it make sense? Don't forget, I'm talking of bond that joins two water molecules together, not the bond that joins a water molecule, hydrogen with oxygen. No. I'm talking of the bond that joins two water molecules together. So here I have three water molecules. This is number one, this is number two, this is number three. Hydrogen bond is a force of attraction that holds them together. That's why when you jump into the swimming pool, it looks like there's a surface attraction. Sometimes it looks like the water is beating you. Did you ever have that experience? When you're even trying to swim, look like the water is not going to separate, right? Look like there's a pressure on the water. Oh, the last time you jumped into the swimming pool, you went straight on into the floor, onto the floor. Who was that? Nobody, right? Anytime you jump into the water seems to absorb you, right? Seems to have a surface that will not let you just go inside. It splashes, right? As though there's a force pressure that came upon it, but it's not like it will go into under the floor, right? That's because there's hydrogen bond connecting it together. Let's go now. We've talked about these chemical bonds. It's very interesting, so we have to spend time with it. All right, what else do we have? I've talked about this, right? Good. Now, I've discussed it, right? Single bond, double bond, very good. Now, force of attraction, hydrogen, I've discussed it, right? Good. And this is what I was talking about when I'm talking about the bonds. You can see? You can see the bonds? Now, you can see this guy. What's the name of this guy? This is oxygen, and this is hydrogen, right?
Yeah.
You can see electrons are closer to this side and you can see the way they are pulling it. This is electropositive. This is hydrogen is more electropositive. Oxygen is electronegative. So it's going to attract more electrons. Now, a chemical reaction occurs when bonds are formed or broken. So, did you remember anything about thyroid gland?
Oh, what?
Thyroid gland.
Thyroid?
Gland. What can you remember about it? Metabolism. Anytime you remember thyroid gland, think about metabolism, right? Right? Now, and when you remember metabolism, what are the two types of metabolism that you think of? Anabolism and catabolism. Anabolism means adding bolism. Catabolism means cutting bolism. All right? Anabolism is adding bolism. Catabolism is cutting bolism. And now, ana is building up. Kata is breaking down. So, chemical reaction can either be to build up or to break down. Now, if you have hydrogen, if you have this plus this the other time gives you H2, right? Hydrogen atom plus atom gives you hydrogen molecule, right? This side is what we call the reactant, and this will be the product, right? Good. That's just so the ending is it now. Okay, I have to be fast now. Let me clean this up so that you can see the PowerPoint well. I'll be doing less of writing now since I've finished those chemistry details more. Can I clean this?
Yes.
Okay, thank you.
No, it wasn't done. No, I'm just playing. Go ahead.
I'll take 10 points from your score. You're happy? I'm just kidding.
I'm reading the negatives.
All right, now let's go. Energy transfer. When we say exit, anytime you hear X is EX, think about exit. That's the first thing you should think about. If any other case, when it becomes different, like example, forget about that. But anytime you hear EX and EN, think about exit and enter. Does it make sense to you? EX and EN as opposites. Think about exit and enter. So hexagonic reaction is the time. It's what happens when you have energy exit or energy released into the environment. That is hexagonic. Does that make sense? Good. So that happens in the case of cellular respiration, right? Cellular respiration, when you break down food molecules to produce ATP. Don't fret. You don't know what cellular respiration is. It's okay. The last time you heard, I'm trying to remember myself. Okay. Now, so this morning I was rushing out and I felt, let me just snack on 3 slices of bread. And thank God I did that because that's all I've had today. I've just been busy and I didn't have time to eat. And so I've had 3 slices of bread. And I was thinking I would drive Chick-fil-A before this class and I didn't have that time all through. Now, I had 3 slices of bread. But great that I had it because that's what I'm using now. The 3 slices of bread is carbohydrate, right? Then it broke down, cellular respiration, and I'm getting ATP from it now. So the way I'm moving all around now is because of the 3 slices of bread. So kudos to the 3 slices of bread that I had in the morning. Now, so that is cellular respiration. Cellular respiration is to harvest energy from the food you ate. That's simple. Does it make sense?
Yes.
Is to harvest ATP from the glucose you had. Now, I'm getting energy from what I had. Energy is released, right? That is exergonic. Endergonic is the same thing as photosynthesis. The plant traps sunlight. Sunlight is an energy, right? The plant traps sunlight and use it to make a product. So that is trapping energy, grabbing energy to make something. So that is endergonic. Does that make sense? Good. I don't think I should write the formula for, I would normally write the formula for photosynthesis and cellular respiration, but if you need it, just let me know. I can write it just to have it. Metabolism, I've talked about this over and over, right? Catabolism and anabolism. Let's go. Now, any compound you have in your system that have carbon is usually organic compound. Now, not just that have carbon, because CO2 is not organic compound, is any compound that have carbon as its skeletal structure, as its backbone. All right? That what determines it is carbon. So something like glucose is an organic compound. So when you say how many carbon does this have, and it has 6. Once I hear that it has 6, I think most likely that it will be glucose. So that is an organic compound. All right? If I hear of another compound that have a particular number of glucose, carbon, I can say this is an organic compound. So most compounds that have carbon as its skeletal structure, they are organic compound. So it usually sometimes can have carbon, and it may have hydrogen, it may have oxygen, and those are. But if it is simple and it doesn't have carbon, then it is mostly inorganic compound. Let's go. Now I've explained polar covalent compound the other time, right? So let me just explain this. Now, when you say polar molecules, they exist in solid, liquid, or gas form, and they are excellent solvents. They are used to dissolve things. So anything you can remember that helps to dissolve anything, it is polar substance. So hydrophilic substances that dissolve in water. Hydrophilic substances. Now, philic means friend. Hydro means water. Friend or loving. That's philic. So when you hear phobic, obviously you can remember phobic from phobia, right? From the phobia. When you say phobia, it means scared. So water-scaring substances do not mix with water. So like oil will not mix with water, right?
Yeah, oil.
Those are hydrophobic substances. And let's go. Water is involved in metabolic reaction, obviously, you know. Dehydration reaction, what's the meaning of dehydration reaction? What does it mean? What's dehydration? When you hear dehydration, what does it mean? When you say you are dehydrated, what does it mean?
You're thirsty.
Removal of water, right? Water is removed from your system. So, now, dehydration reaction, remove water to make a bond. Remember that. Don't ever forget that. Removal of water to make a bond is dehydration reaction. You may want to write that. Removal of water to make a bond is dehydration reaction. Dehydration reaction, removal of water to make a bond. Dehydration reaction. Then hydrolysis or hydrolytic reaction. We call it hydrolysis or hydrolytic reaction. Now when you say hydrolysis, lysis means break. Hydro. So hydrolysis. Lysis. To lyse is to break. Hydro is water. So it's breaking a bond with water molecule. So it's addition of water molecule to break a bond. So it's opposite of dehydration. Dehydration is removal of water molecule to form a bond. Hydrolysis is breaking a bond with water molecule.
Okay, now.
Dehydration, removal of water molecule to form a bond. Bond, B-O-N-D. Should I continue to hydrolysis?
Yeah, explain the second one again.
Hydrolysis is addition of water molecule to break a bond. So one is break, addition of water molecule to break a bond, hydrolysis. Dehydration is a removal of water molecule to form a bond or to build a bond. Make sense?
Yeah.
Good. I will skip things that I feel I don't want to talk about again. Just read this up, look this up. Mixture, those are chemical compounds, chemical blends that blend together but do not react with each other. Now, solution is solid plus solvent, right? What is solvent? Solvent is what is dissolving. From the word solvent, there is solve in solvent. So the way I joke with it is this: solvent, right? Then remember the word dissolve. So anytime you hear solvent and dissolve, anytime you hear solvent, always remember it is what is dissolving the solute. The solute is what is concentrated. The solvent is what is dissolving the solute. Make sense? Good. So solvent is what is dissolving the solute or reducing the concentration. Then colloid is when the solute particles are larger and they remain evenly distributed in the solvent. Just look at that suspension. Just look at that. I'm not too much keen about that. Now, inorganic acid, bases, and salts. Acid, they increase hydrogen concentration. So anytime when you want to measure the acid in the molecule, all you just need to know is hydrogen ion concentration present, right? If there's more H plus, there is more acid. It's more acidic. If it's less, there's less acidic. More OH minus, more base, right? Go ahead.
This might be a dumb question, but it'll help me understand better. So, if you have bleach and you pour water into it, the solvent is water. Yeah?
Good.
Okay.
The solvent is water because it's dissolving the bleach.
Okay.
If you have orange juice and you want to give orange juice to your kid, now I remembered something. So there was recently, about 2 weeks ago, my wife gave my daughter orange juice, but she had mixed it with water because she wants to reduce the quantity of sugar she's taking. And my daughter said, "I don't want water juice." She was like, "Mommy, I don't want water." She didn't know why she was mixing it up. She just gave it to her in a bottle. So there are two of them, right? So the older ones, they both have their bottles. I think we were driving. And I was just hearing her saying, "Mommy, I don't want water juice. I want orange juice." And I'm like, she doesn't even know when my wife mixed the juice. She only knew that the taste is different. So what my wife did at that time is the orange juice, even though they are both liquid now, the orange juice is the solute, the water is the solvent. So my wife reduced the concentration of the solute. So that means the water is to dissolve the orange juice. And my daughter said, "This solution is water juice."
Water juice.
She was like, "Mommy, I don't want water juice. I want orange juice." All right. So let's go. Now, acidity, when you look at the pH is 0 to 14. 0 to 7, 7 is neutral. Below 7 to 0 is acidic. Above 7 to 14 is basic. Does that make sense? Good. Don't forget that. And pH is not measured in 1, 2, 3, actually. pH, yes. So this is acidic. This is basic. This is neutral. Your regular pH is between 7.35 to 7.45. That is the pH of our blood. Now, you can see 10 and 10 here, right? So the difference, so pH is measured in log reading. So the difference between 1 and 2 is 10 raised to power 1. Make sense? So the difference between pH 1 and pH 2 is actually 10 raised to power 1, meaning it's 10. The difference between pH 3 and pH 1 is 10 raised to power 2. Make sense? So just take note of those keys. Let's go. Now, if not for COVID now, I like to do an experiment with this. What is a buffer? That's where I will just go there and I'll leave that slide. A buffer is anything that helps to resist changes in pH. A buffer help to resist changes in pH. So if you eat something that is acidic, our body have its buffer system that helps to normalize your pH straight. All right? So buffer is anything that helps to resist change in pH. So buffer helps. So that's another kind of homeostasis, right? So usually you have bicarbonate in your system. Bicarbonate, which helps to maintain that system. So bicarbonate is a buffer. It helps to maintain pH. Now, I've talked about this. You remember?
Yes.
Smaller chemicals join dehydration reaction, right? When you build bond, it is dehydration reaction. Break bond is hydrolysis, right? Then, when you add two smaller molecules together to form a bigger molecule, that is polymerization. So, monomers are small molecules. Polymer as big molecules. I'll still be talking about carbohydrate, all of that. So, when I talk about that, I'll discuss polymer and monomer very well, okay? So, let's go. Okay. Somebody quickly look at my syllabus, calendar, and tell me how many days I have for this chapter.
No, what?
How many slides?
How many days? How many days did I put for this chapter? Real quick. Today?
Yeah, it just says 8:30.
The next day after, is it blank or is filled?
It has chapter 3.
Chapter 3. All right, let's go. How many minutes do I have more?
It's at a 44 and here I'm 24.
So how many minutes do I have more?
20.
I have 20 minutes for this lecture?
I thought you were talking about slides.
Oh.
Oh no. How many minutes do I have more? If I have 20 minutes, that's a blessing.
It's still 42.
How many minutes do I have more?
None.
None? Lecture none? All right. So this is it. Let me push a little more. When I get to a little convenient point, I will stop. Then we'll continue to the lab, okay? But you guys are still fine, right?
Yeah.
Okay, good. Now, we'll look at carbohydrate, lipids, protein, and nucleic acid. Now, I want this to be very interesting to you because that's your food, all right? I've once asked some of my students, what are the classes of food that you have? Some people tell me we have dairy, we have, now, so, very good. Now, those people were telling me the classes of food that Walmart does, how they pack meat to one side, dairy, all of that. So, those are not your classes of food. These are your classes of food. Carbohydrate, lipid, proteins, nucleic acid, right? So, let's go. Let's look at carbohydrate. This is very fun. You will enjoy carbohydrate. Maybe after this class, you'll be eating more of carbohydrate, but I will advise you not to because so that you don't increase your sugar too much, right? Good. Let's go. I've talked about dehydration reaction, right? I've talked about hydrolysis. Now, but there's something I want to talk about here real quick. Look at this very smartly. I'll be on this slide and I will talk a lot about carbohydrate and I may just finish carbohydrate. So, look at this. I actually sprayed it on myself. So, Matt, you are laughing. It's fun, right? I'll take 10 points off.
I'm already -10. Now you got me -20.
I'm just kidding. All right, now carbohydrate. Listen, so sharply. Number one, we have what we call monosaccharide. You like the name?
No.
Number two, we have disaccharide. Now, saccharide is not anything, it's just another language for sugar. And the third one is polysaccharide. Saccharide is just sugar, okay? Something that's sweet, Now, monosaccharides are FGG. Disaccharide is LSM. And this, I'll write the list because I never did an acronym for it. Starch, cellulose, chitin, or chitin, they are all in that category. Now, what is the FGG? You have the fructose, you have the glucose, then you have galactose. And this, you have lactose, you have sucrose, and you have maltose. Lactose is what you see in your milk. That's why some people have lactose intolerance and they are not able to drink milk because they don't have lactase. Lactase is the enzyme that breaks down lactose. Anytime you hear ASE, it's an enzyme, right? Good. So lactose is an enzyme. So monosaccharide or simple sugars, they have fructose, glucose, and galactose. These are what we call monomers for carbohydrates. These are monomers for carbohydrates. What are you looking for?
The last word on polysaccharide, what's that one?
Is CHITIN, chitin or chitin. CHITIN. Now, so monosaccharide, what are the monomers for carbohydrates? Is these three: fructose, glucose, and galactose. Now, look at what we have here. Look at your slide. You will see that you have glucose plus fructose giving you what? Sucrose. So monosaccharide plus monosaccharide giving you disaccharide. Does that make sense? Then, what did you notice in between them? You can see dehydration to form a bond. So this is OH from this end, hydrogen from this end, they form this H2O. Now let me come here. So this OH is removed. H is removed here, it forms this H2O. And you remember I told you dehydration reaction is removal of water molecule to form a bond. So the bond was formed here. This was removed. This was removed. So water molecule was removed here, H2O, and the bond was formed right there. Make sense?
Perfect.
Good. So that is dehydration reaction. So when two monomers come together, they are going to lose hydrogen and hydroxyl, meaning that they are losing water molecule, right? Then a bond is formed. And this is the general rule, not just for carbohydrates, it's a general rule for everything, even for proteins, everything. Make sense? So water molecule, so glucose, sucrose is formed there. And you know sucrose is your table sugar, right? That's sugar you eat. All right, so that is that. Then hydrolysis, I can reverse this reaction. If I want to reverse this reaction, the second reaction there is a reverse of the first reaction. Reverse means that I can get back my sucrose, my simple sugars, right? I can get back glucose and fructose. And what would I do? I'll just add the water molecule back. Once I add the water molecule back, which is what happened here, the bond will break. So addition of water molecule to break a bond, to lyse a bond. That is hydrolysis. Make sense now? Good. Should we go? All right. Now we've talked about this, right? Right?
Yes.
And you know carbohydrate provide energy, right? I told you, did I tell you last week that protein is what performs the activities in your body, right? Carbohydrate supplies the energy. Protein does the work. So I've talked about all of these, right? Did you remember?
Yes.
I've talked about sucrose, maltose, starch. Just look at that. And that's it. The last one is lipid. I'll just rush through lipid. There's not a lot. Oh, there's one thing I want to talk about that you must not forget. You can see the bond formed here. This bond, make it your friend. The name of this bond is called glycosidic bond. Don't forget that bond. Glycosidic. You must not forget that bond. So, key things you must not forget. The monomer for carbohydrate is called monosaccharides. And the monomers are fructose, glucose, and galactose. What's the name of the bond formed? Glycosidic bond. You don't want to forget that. Let's go. Lipid is hydrophobic, you know that already, right? We've talked about it. It stores energy. Now, I hope you know that lipid supplies more energy, about 2.5 times more.
What is?
Lipid, it gives you more energy.
Lipid?
Lipids gives you more energy than what carbohydrate gives you. The only thing is this. Think about it. If you have a friend that gives you $2 to eat every day, and you have another friend that gives you $5 to eat every day, but the difference is this. The one that gives you $5 can only give you when the one that gives you $2 is not available. Does it make sense?
Yeah.
You have a friend that gives you $2 every day to eat.
But if he's not
Another
giving it
friend
another, but he gets me
can give you
five.
$5 every day. But you can't get the $5 if the $2 guy is around. If the $2 guy is not around, the $5 guy will give you. That's glucose and galactose. Glucose and lipids. Glucose give you energy normally. Readily available is the guy that gives you $2 energy every day. But lipid gives you $5 energy.
You saying lipid?
Lipid, L-I-P-I-D. Lipids. Lipid.
I don't know what.
Lipid is fat. It's right there on the top.
Oh, up top. Okay, good. Didn't even know.
So lipids give you more energy, but lipid can only give you the energy when carbohydrate is not available. That's why when you fast,
Why is that?
that's why when you fast, either when you don't eat for some time, then your body break down the fats to use it for energy.
But why does lipids not give you energy every day? Or whenever?
It can give you every day, but it cannot give you when carbohydrate is available. Carbohydrate is actually your first energy supplier. When carbohydrate is not available, then you begin to burn your fat. Because this is your fat are stuck in your muscles, right? They are there. So when you don't have ATP, when you don't have glucose, then your body begins to burn the fats that are stored in your muscles, right? It's work. Your body will not burn those fats until it's pulled to work, until it's stretched. So that's why exercises also help to burn the fat, right? Because your body will have been heated up at that time. So energy, all I'm just saying is that lipid gives you more energy than ATP and carbohydrate does normally. Lipids have more energy in stock. So example of lipids are fat, phospholipids, steroids, eicosanoid. So these are example of lipids. Now, okay, I don't need to talk about that real well. Let's just go. Saturated fats contain single covalent bonds. That's what you see in your butter and lard. Now, you will notice that saturated fats are solid at room temperature, right? Those are the fat from animals, right? They are not healthy. But the fat from plants are more healthy. That's why you're advised to eat vegetable oil, all of that, coconut oil. They are more healthy, they are less saturated, and so they can be digested faster and easily than saturated fats that will solidify at room temperature. And when we say saturated, it means it does not have double bonds. Saturated fats does not have double bonds. It has a lot supply of hydrogen, so it has a lot of bonds there, and they won't break easily. I'm just trying to rush up now. So phospholipid is another one. That's what you see in your cell membrane. Have you ever heard of phospholipid bilayer? Phospholipid bilayer, that's what you see in your cell membrane. That's just your representation of it. Steroids is another form of lipid, and you've heard of steroids, right? Good. You have sex hormone, cholesterol, and it's also part of the cell membrane. You can just read through this. It's not much. Okay, good. Now this is protein. I talked about protein last week, right? Did you remember? Very good. So just take note of the functions of protein that I have here. And I already talked about the type of protein. Now, key thing I'll talk about protein is what's the monomer for protein? It's amino acid. Monomer for protein is amino acid. Protein also go through the kind of reaction that carbohydrate go through. What's the monomer for carbohydrate? Very good. It's monosaccharide and it is fructose, glucose, and galactose, right? But for protein, the monomer is amino acid. And you know we have amino acid, right? We have glycine, leucine, phenolphthalein, valine, tryptophan. Those are amino acids. Now, they also go through the dehydration and hydrolysis reaction. If two amino acids want to come together, which type of reaction will they go through? No, I'm talking of reaction. You are correct. Anabolism is to build up. But you know we have two types of reaction, dehydration and hydrolysis. So if two amino acids, two monomers want to come together, what is the reaction they will go through? Dehydration, because it's the removal of water molecule to build a bond. When you remove water molecule, you are building a bond. When you add water molecule, you are breaking a bond. So water molecule builds bond. When you remove it, when you add it, you are breaking a bond. Make sense? Adding is breaking, removal is building. So when you add two amino acids together, it will be forming what we call peptide bond. The name of the bond is peptide bond. Don't forget the name of the bond I said for glucose is what? Glycosidic, right? But for amino acid is what? For protein is called peptide bond. Peptide bond. And when two amino acids are joined together, they will be forming what we call polypeptide, which is what you have there. Polypeptide, right? The name of the bond is peptide bond. Peptide bond, right? It's a form of covalent bond too. So let's go. So I've talked about primary protein, secondary protein last week. So you just read through again. Did you remember this word from last week?
Yes.
Thank you. And you remember I told you it means to denature. For protein to lose its nature. And that's why I told you when your temperature is getting to 104, what did they say? Rush to the emergency, right? So that protein will not be denatured. All right. Enzymes are protein. I told you last week that most enzymes are proteins, right? Did you remember? Good. That's why I was telling you that anytime you see protein, you respect, because protein is doing a lot of work, right? Good. All right. And I told you already that enzyme ends in ASE, right? Anytime you see anything that ends with ASE, it's an enzyme. So when you see lactase, it's the enzyme that breaks down lactose. If you don't have this enzyme, that's why you don't drink milk. If you drink milk, it will give you heartburn or you have some discomfort because you don't have the enzyme that breaks down lactose. And what's the lactose? Lactose is a disaccharide. Before lactose will be useful in your body, it has to be broken down to monosaccharide, right? Because it is monosaccharide you can harvest ATP from. So your body has to break this down to monosaccharide, then your body go through cellular respiration to bring it to harvest ATP from monosaccharide. So if you don't have lactase, your body will not be able to break down the energy that is stored in this lactose. If you eat potato, which is starch, and you don't have the enzyme amylase to break it down, your body will not be able to get the energy from the potato. So you have challenge digesting it. Make sense? All right, so we can go. Now, the last thing I'll talk about, which is key, don't forget this. It's the last thing because I have just 3 slides more. So I'm just going to talk about this and you'll be going. Now, there's something we call nucleic acid. This is my best friend in this class, okay? Nucleic acid. My best friend was Maria the other time, but now it's nucleic acid now. Now, when you say nucleic acid, there are 2 types of nucleic acid. There is DNA, there's RNA. DNA is what determines your identity, right? DNA, your genetic mechanism. DNA is deoxyribonucleic acid. RNA is ribonucleic acid. What's the difference between DNA and RNA? One is deoxy, meaning that one does not have oxygen at a point. One lost one oxygen, the other doesn't have it. So deoxy, meaning that it's losing an oxygen at carbon, I think that's carbon 2 position of the glucose. Don't bother about that too much. Now, this is the monomer, nucleotide is the name of their monomer. All right? So the monomer is nucleotide. The bond is ester bond. There's another name, phosphodiester bond. So that's the name of the bond formed. But nucleotide is made up of 3 substituents. Number 1 is pentose sugar. Pentose means 5. It means 5 carbon sugar. Then phosphate group and nitrogenous base. This nitrogenous base can be 4. For RNA, okay, I'm going to do it this way. The nitrogenous base for RNA is, and the nitrogenous base for DNA is, I'll write it on the board. Everything will be on the PowerPoint, but for things like this, I prefer to teach it straight without PowerPoint. I feel it will make you grab it more. You'll be able to write, then you can just suppose things with your PowerPoint later. So DNA, RNA. The nitrogenous base, that's what I want to do. DNA have thymine, guanine, cytosine, and adenine. And RNA has uracil. Instead of thymine, RNA have uracil. But it has the others. Cytosine and adenine. Another thing is this. DNA is double-stranded. RNA is single-stranded. Another thing is this. DNA have the oxyribose sugar. RNA have ribose sugar. The only difference, the reason is this. The only difference is this. So I'm writing when you should also be writing. Some of you are taking pictures. It's okay to take the picture so that I don't clean it, but make sure you write. It's a way of learning too, okay? It's not punishment, it's a way of learning. When you write, you are learning. It's a way of memorizing things.
I can't see the second and third one on the right-hand side.
This?
The second and third word on the right-hand side.
On the right-hand side. This is single.
Up top. The second and third one. They start with a G and a C.
This?
Yeah, how do you
This is
that?
guanine. G is the same thing. Guanine. Let me see if I have it on the PowerPoint. Guanine. Yeah, it's on the PowerPoint slide.
Okay.
You can see it, right? So the rule is this. A pairs with C, G pairs with C. That's the rule everywhere. So for this, A will pair with U, G will still pair with C. The same rule. Let me see if there's anything I want to explain here again before I let you go. All right, I think that's it. I'll see you in the lab. You can take like, okay, no, don't go yet. Somebody have a question. Attendance. Thank you. All right.